Okay, now we are going to discuss the meaning of the radius of convergence. Well, before that, let's summarize the details that we have done so far. In the previous videos, we have discussed the convergence of these two series, right? And in the same way, you can even do get the limit of the ratio of this series as well. Actually, the third series has a very special name, and that is called the Bessel function of order 0, right? That name is not that important at this stage, but just focus on this ratio through the limit through the ratio test. Okay, right. So when you get the ratio, you can see now in the first example, you can see that the limit is infinity for all x not equal to 0. Now I need to say a few words about this x being not equal to 0, right? So this same series can even be written as n factorial x minus 0 to the power n, right? So actually this number, like if we get the most general form of the power series, it can be written like this. Okay, so this number it is called as the center. Okay, so it's like kind of the center of this power series, and so when you substitute this number, right, let's see what will happen when you substitute that number. If you take this series, right, and then directly plug in x equals a to this series, right, then at once you might observe that when you plug in x equals a, then this term will be 0. So what you will have is something like this. Therefore, it is a number multiplied with 0. So the result is 0, right? Sometimes you might tend to do this calculation, right, which is not correct. The reason behind that is this sigma notation is actually some sort of a short form of a certain expansion, and that expansion is this one, right? C1x minus a1, C2 x minus a2, like this. Now this is actually the short notation of this expansion, right? So here you should observe that for the 0th index you don't have any x minus a term. That is, the 0th index is the starting position, and there in this starting position you don't have any x minus a term. So if you are substituting x minus a, you will be doing it for all these other terms, right? Therefore, you will anyway have the C0 term remaining, although the other terms vanishes. Like let's take a specific example. Let's have this as n plus 1. Okay, so this will be equal to Cn x minus a n, right? And this will be the term corresponds to n equals 0 will be C0, and that is equal to 1, and this is to the power 0, and that is just 1. That's kind of a convention that we use. Okay, so when you have a 0th index or the 0th power, you consider it as 1, right? So basically for the expansion, what we have is this one, right? X minus a1, x minus a2, likewise, right? So when you substitute a certain number, those numbers will replace these terms but not the first one. But this idea, you will not directly see this idea if you try to plug in this x minus a value at once to this concatenated sigma notation, right? If you just plug in x minus a, then this will be 0. So it's like something multiplied with 0, leaving out with 0, and that is not correct. Okay, so you have to keep this expansion idea in mind. But of course, if the series starts at 1 and if we have the same thing, then what you have is you have the series starting from this term. Okay, then if you substitute x equals a, you will get 0, right? So you have to be careful when you plug in this center number, right? So this problem only arises when you plug in this center number. Now for this example, the center number is 0, right? So when you plug in 0, there will no longer be a series, right? You will only have now if we expand this one, it will be for n equals 0, you will get 0 factorial plus, and for n equals 1, you will get 1 factorial x1, and after that for each and every term you will get a x term here, right? And when you substitute x equals 0 for this expansion, you will still have this 0 factorial term. So in other words, for this series, when you substitute x equals 0, the series will be equal to 0 factorial, and that is equal to 1. See, from the series, for this particular value, you have a finite answer. In other words, this series at this x value converges, right? So that will that is the reason for mentioning this x not equal to 0 thing here, right? Other than that, for all the x values, the limit from the ratio test will be equal to infinity, which is greater than 1. Therefore, the theory of ratio test says that the series diverges. So, as a summary, what we should have in mind is this series will diverge for all x values which are not equal to 0, right? 0 is the center point. And generally, if you consider any power series, that power series will converge for its center value, right? Because when you substitute the center value, you will only get C0 as the answer, right? The series will be equal to this first term of the sequence Cn, right? So this is one thing that we should keep in mind when you have a power series. For the center value of the power series, it will converge, right? and we will study more about the radius. Now still I did not introduce you to the exact meaning of radius, and we will do it in the next video.